Today's program is happy number. Happy number is a number if the sum of its squares of its digits reaches 1 at the end after subsequent calculations. If it reaches 1, it is a happy number. If it doesn't reaches 1 and it reaches a single digit number, it is not a happy number. So example of happy number are 7, 19 and 100. This is the program for happy number. So here we are using recursion because we are calling the method. It is recursion, and I will walk you through the whole program. So hi, I'm CJ and welcome to Education Valley. Today we have another amazing video on the Java program. So let's do it. Sum of the squares of the digit is equals to 1 subsequently, not at the first attempt, but eventually it gets to 1. When will we abort the program? If it comes to a single digit without coming to 1, we will abort the program. So we have taken example of 19 to check upon here. Okay, 19, so 1 square plus 9 squared is 1 plus 81, it is 82. After that we broke down 82 and both square 68, then we both broke down 68 and 36 and 64. It came down to 100. Whenever it comes to 100, of course 1 square will be 100 and it will eventually reach 1. Since it reaches 1, it is a happy number, and if it wouldn't have reached 1, it is not a happy number. These are the examples of happy number. 3 examples. There are more numbers like that. So let's go to the program. So we are using objects and methods to do the tasks. We always use objects and method, but we are creating and calling methods in this program. So the basic thing is, let's just do the void main method. So we're creating an object to take the scanner input. We create an object, then we enter a number and take a number in using this object in nz. Then we pass the nz to get a number. When we call it, it gets called and it initializes to n comes. Nz is passed to nm and nm gets to n. Okay, after that in is happy is called and sum dot is happy calls sum of the digits n is passed down to here. Basically this is the n which was declared here, and it comes down to x is the number. Like for an example, we have entered 19 and it has reached this method to give us the output. So return x modulus 10 into x modulus 10. Why x modulus 10? Because see, like we have to extract digits, right? So first we will extract one digit. Like we have to just take an example of 19. So first of all, here will be 9 into 9, so 9 square, and then we will call the method back after removing 9. So it would have worked if, for example, we need this because we don't know how many digits are there in the number. So we just, whenever you divide by 10 or modulus 10 gives the remainder, and divide by 10 gives the quotient. It just removes the last digit. So here, let me show you how that works. I must have it somewhere. So if we take from here and copy it to our happy number, okay, let's see as happy number. Okay, so we copied it. So let's take 19 and divide it by 10. So 19 divided by 10, it will be, how much will it be? 10 1 jar 10, and it will be, remainder is 9. So the rule is that the number of digits you want to remove from the last, you divide it by, like for example it will be 87. For example it will be 87. So if you want to like say extract 19, so you will have 2 digits. Yes, you add two zeros and it will extract 19. So how much it will be? 87, 87, and it will be 8700. So 19 will come. So we'll have 19. So and 87 will come in the question. So same way, if we have 19 in our, if we have 19 in our 19 here for in our example, so 9 is extracted as from the modulus, and 9 into 9 multiplied 2 times, that's square basically, and then we call the method and remove 9 from that number. So it 9 is removed from here and x is equals to 0. This is the method that keeps checking, and we are also adding plus. So this is happening in the memory. In the memory we are adding return 9 to 9 81. After that x becomes 1 because 9 is removed, so x becomes 1. 1 into 1, it will add again, and plus sign, it will call the method again. X is equals to 0 will is again true. X equals to 0, x is 1, x is greater than 0, yes. After that it will 1 into 1 plus, since okay, so here we will divide. Again we are dividing 10, but this time it is, all we have is 1, so it will not divide, it will be 0. 10 zeros are 0. That's the only way 1 is divided, and we will have a remainder of 1. So x becomes 0 and this condition fails and it's returned 1. So until now it was adding, so here is a plus sign, so it was in the memory, it was sent 81 plus, after that it sent 1 plus, and at the last it sent 0 and returned it. So 81 plus 1 plus 0, it will return 82. 82, it returned 2. But first we do one division and then we go to and check if it is greater than 9, because I mean until it is double digit, we have to keep reducing it. So what we do is, while 9, we send it b is equals to sum of square of the digits. So 82 is passed again, and we go through the same thing, and it will pass to 64 plus 4 plus 0. 4 plus 64 plus 0, it can come down to 68. While b is greater than 9, yes, b is again greater than 9, so this will execute again. This will call the function 68. It will be then 8 will be extracted, 8 into 8, then method will be called back. So it will check again, x is still greater than 0. So it is 6 into 36. So after that, because it will have 6 x is greater than, after 6 it becomes, like last time it becomes 1. Like let's take again, so it is 68 at this point of time. It's 88 square passed on 64 in the memory. After that 6 square 36 passed on in the memory. 6 square 6 will be divided by 10. It cannot be divided by 10, so it will result in 0, because 0 is the only way it can divide. So x becomes 0 and adds 0 and it enters 100. After 100, 1 square, 8 square, 0 square, it will be 1 plus 0 plus 0 plus 0, it will be 1 and it will reach a single digit. So while loop will terminate, this terminates, while loop terminates, and check starts. If b is equals to 1, it is a happy number. If b is not equals to 1, it is not a happy number. So this was the program. I hope you understood it. Thank you for watching.